This is lesson 511, sine and cosine ratios. While on vacation, your friend climbed the steepest street in San Francisco. So that would be this street right here. Her guidebook said that the street had a slope angle of 17.5. And after walking 100 feet up that hill, she wanted to know how many vertical feet she had climbed. So that would be this right here. Could we do this with tangent? Well, normally our tangent ratio we've learned is change in y over change in x, and we don't have either of those. So if we normally did this problem, we'd be saying tangent of 17.5 equals, and then we don't have anything, right? We have two variables instead of just one. So no, we can't do this with tangent. It turns out there are going to be other trig ratios other than tangent, such as sine and cosine, and we'll talk about those in just a minute. But before we even talk about those, there are parts of a triangle that we need to learn their names and their characteristics. So each side is based off the angle that we're focusing on. So here is the angle. If you need a reminder, this is called theta, right? And that is just showing us a generic angle. So the hypotenuse is the same as it's always been. It's been the longest side and across from the right angle. Adjacent. Adjacent is another word for next to. Okay, so the adjacent side is going to be the side that is next to this angle or touching this angle, right? The angle's right here, so the adjacent side is next to it. And then the opposite side is the side opposite the angle. So it's the side that doesn't touch that angle whatsoever. So doesn't touch the angle. Okay? And that's going to be the same no matter how your triangle is oriented, okay? And so before last chapter, we were focusing on needing to reorient the triangle. We don't need to do that anymore. So using that information, the sine ratio we're going to use when we are using the opposite side and the hypotenuse. So we don't need the adjacent side. And then the cosine ratio is for when we're using the adjacent side and the hypotenuse side. Okay, that might not make sense at the moment, but we're going to do some problems to show you. So for instance, the angle that we're focusing here is 60. Okay, so 2 is the hypotenuse because it's the longest side. I always like to put H or HYP for hypotenuse. This is the adjacent side, this one right here, because it is touching the angle, right? It's touching that angle, and it's right next to the angle. And then this square root 3 right here is the opposite side because it's opposite the angle and it's not touching that angle at all. So use a trig ratio to solve for A. Oh, you know what? We should do our sine and cosine ratios here. So sine, the opposite side was square root of 3. So that would be square root of 3. And the hypotenuse was 2. So that would be the sine of 60 degrees is equal to the square root of 3 over 2. And then the cosine of 60 would be the adjacent side is 1 and the hypotenuse is 2. Okay, so that's kind of how we'd set this up. So we're going to use a new trig ratio to solve for A. Here is our angle that we're focusing on right here. Right now it's in the bottom left corner, but again, it doesn't need to be. This is the hypotenuse right here, 15. And then this A is not touching the 23 degree, it's opposite. So that is the opposite side. So if I think about which ratio uses hypotenuse and the opposite, that is the sine ratio, okay? So that's going to be the opposite side, A, over the hypotenuse, 15. And that's equal to the sine of our angle, 23. Okay? Then we can get to actually solving these, right? I can put sine of 23 over 1. And then I could cross multiply to solve for a. So I'm going to cross multiply the sine of 23 times 15 gets me 5.86, and that's equal to a. So this opposite side right here is 5.86. All right, now we're solving for b, different angle, different everything. So the angle that we're focusing on is 37. We have a hypotenuse in this picture, again, longest side across from the right angle. And we have an adjacent side here. It's touching that angle. So that's our adjacent. So a dj. So if I think about which one uses hypotenuse and adjacent, that one is cosine. So we're using cosine in this one. So the cosine of our angle here, and remember that's adjacent over hypotenuse, so that's going to be b over 8. And I'm going to put cosine of 37 over 1. Cross multiply. The cosine of 37 times 8 is 6.39, and that's equal to b. So b right here is 6.39. Okay. So going back to the San Francisco problem, now that we have a trig ratio, we could find both of these, okay? So let's start with this distance here. This is our opposite side, and this is our hypotenuse, okay? And our angle right here is 17.5. So for that first one, this would be sine of 17.5 because sine uses opposite over hypotenuse. So the change in y, let's just call it y, over 100. Okay, and then we can cross multiply so that y equals, and let me type this into my calculator. This is 30.07. Okay, so that is 30.07. Now, in order to find the other one, now I'm going to use the other side. Okay, this is my adjacent side, so I'm going to use that one and the hypotenuse now. And adjacent and hypotenuse is cosine. So now the cosine of 17.5, I'm looking for the x and the 100. I'm going to cross multiply, and that is going to get me 95.37. That side down there is 95.37. So one thing I want to mention is when you are choosing your ratio, trying to figure out if it's sine, cosine, or tangent, there's a fun little phrase that we use called SOHCAHTOA, okay? Some people write it out as SOHCAHTOA, and then some people write it out SOHCAHTOA. I personally like this bottom one because I think it's a little bit more clear. But here's what we're looking at. The S, the C, and the T stand for sine, cosine, and tangent. Okay? And then everything else, like the O and the H, the A and the H, and the O and the A, the O stands for opposite side. The H stands for the hypotenuse, and the A stands for the adjacent. So if I can remember the phrase SOHCAHTOA in my head, if I think about, hey, I've got the opposite and the hypotenuse side, SOHCAHTOA, that's going to be sine. I'm going to be using sine for that, okay? And it helps you remember which one should be on top and which one should be on bottom. So I would highly recommend always writing SOHCAHTOA on your paper whenever you're about to start a problem. All right, so I'm going to write my SOHCAHTOA over here. just to remind myself, the angle that I'm looking at is 17, okay? This is the adjacent side and the hypotenuse, and we don't have any information on the opposite side, so we're just going to be using the hypotenuse and adjacent. If I look at which one that is, hypotenuse and adjacent, that is the ca in SOHCAHTOA. So we are using cosine for this problem. So the cosine of 17. Now here, A is on top. The adjacent side is on top. So that's going to be 3 over x. Okay? Then I need to cross multiply. So cosine of 17x equals 3. Okay? Now, if I look at what I need to get rid of, to get x by itself, I need to get rid of cosine of 17, right? I need to divide by the cosine of 17. And this can be kind of confusing for some people. So sometimes what I tell people to do is put this part into your calculator to make it a number, so 0.96 roughly. And then that makes people feel more comfortable about dividing by the cosine of 17 from both sides, because it's really just a number. So x is going to be 3.14 for this problem. So that's 3.14. All right. On to this one. Now notice that our angle is not in the bottom right corner this time, but that's okay. Or the bottom left. That's okay. This is the opposite side over here, x, because it's not touching. This is the hypotenuse, 9. It's across from the right angle. So we are using, when we think about SOHCAHTOA, we are using O and H, which is sine. So this is going to be the sine of 25 is equal to, now opposite goes on top, so x over 9, we can cross multiply. So we're going to get the sine of 25 times 9 equal to x. And in my calculator, the sine of 25 times 9 is 3.8. So x is 3.8. All right, on to this one. We've got 45. This is the opposite side. This is the adjacent side. So we are using tangent for this. So tangent of 45 is going to be the opposite. So x over a. I'm sorry, a is 5. Okay, and when I cross multiply and put this into my calculator, x is equal to 5. Okay, I'm not going to walk through the rest. I'm just going to put down the answer. This first one, we're going to be using tangent. So this is the ratio you should have set up, and then x equals 2.66. For the second one, it's going to be sine, and this is the ratio you should have set up, so that x equals 23.25. And then for the third one, we are using cosine, and this is the ratio, so that x equals 9.4. And then with the style of these notes, we kind of have summaries up here. So in your summary, I would write down SOHCAHTOA, and then maybe draw out a triangle labeling your sides. So the hypotenuse, opposite side, and adjacent side.